Hi, I'm Jim Whattam with First State Woodturners. Welcome back to the shop. This is part 2 of our presentation on an introduction to segmented woodturning. In part 1 of the presentation, we gave you a little bit of background information about what segmented woodturning is, some of the reasons why you might want to consider doing segmented woodturning. We also showed you some of the equipment that probably is already in your shop that you could use to give segmented woodturning a try without having to spend a lot of time on specialized jigs being built or money on purchasing commercial specialized jigs. And then we showed you how to calculate ring size and how to use a couple of simple mathematic formulas to calculate segment length, then how to cut those segments on various types of equipment in your shop, how to glue, clamp, sand, and install a single segmented ring on a solid wood bowl. This is the end product of that project in part 1 of our presentation, a solid cherry bowl that we faced off the outer surface of and then sanded this accent ring out of walnut, glued it on to the rough turn bowl, and then finish turned it and finished it with a few coats of lacquer, and this is the end result of that project. What we intend to do in part 2 of this presentation is to build on the skills that we taught you in part 1. What we want to do is progress into building a fully segmented bowl. So we're going to show you right from the beginning planning stages all the way through the various stages of how you end up with building a fully segmented bowl like this, which is about 8 inches in diameter, about 4.5 inches tall. It's 5 rings with a solid wood base. So we thought we would come up with a very simple project that would be easy for novice segmenters to be able to construct their first fully segmented bowl with. In trying to come up with a design for our project today, what we wanted to do was have a design that had sufficient curvature to it that it would illustrate the effect that curvature has on the width of the wood strips that need to be cut for it. Remember, in part 1, we talked to you about how wood strips, the width of wood strips that you need to create a segmented ring will vary depending on where that particular ring sits in the curvature of the bowl. And we wanted to come up with a design that showed how the effect of curvature would affect the width of the strip. So this is a basic design that we came up with using simply 1/4-inch block graph paper. You can pull designs for segmented bowls like this off of the internet. There are some that we mentioned in the PowerPoint presentation that we will also link to when we post this video on the various social media sites. Certainly you can download those off the internet. You can use computer programs like those that we mentioned in part 1 to design it. This is the old school method of simply drawing it out on graph paper so that you can see visually exactly what your rings will look like, should look like, once you get to the construction stage. Again, these are 5 rings on top of a solid wood base that will be layered once they're all glued in place and will obviously ultimately produce this bowl. What we wanted to do was to come up with a design that wasn't complex in terms of different types of wood. You certainly can use multiple colors of wood within a single ring. Something like this, for example, you could certainly come up with multiple colors if you want. We didn't want to do that in this presentation because we wanted to keep it very simple. You could also add spacers in between the segments as we do here. Remember from the last time we talked about how you would go about calculating the effect of that on your segment length. If the segment length was supposed to be 2 inches, and these are 1/8-inch thick spacers, you simply deduct 1/8 of an inch from the 2-inch segment length and make your segments 1 7/8. The spacer makes up that additional 1/8 of an inch and your ring comes out the right size. But again, we didn't want anything all that complicated. We didn't even want to do anything as complicated as a bowl like this one, which is actually not particularly difficult with the accent ring on the top. But it's something you can consider doing if you want. Just a basic one color ring with different color spacers in between. Again, but for our project, we wanted to keep it as simple as possible to keep all of the woods within a single ring the same. Just made things a little bit more simplistic for your first segmented bowl. All right, let's talk in a little more detail about the specific design that we came up with for our project bowl. As you'll see, this is all handwritten again on a piece of 1/4-inch block graph paper. Again, chosen because this very easily illustrates exactly what our ultimate ring diameters are going to be. The ring diameter for the top ring will be from here to here, for the second ring down from here to here, so we can measure those with a ruler and it will give us the exact ring diameter that we need for each of those rings. All of those ring diameters are listed in the chart that's at the top of the page. Also, remember last time we talked about the need for a fudge factor or padding in the ring that you're doing. For example, the ring that we have on top is ultimately about 8 inches in diameter, as I said, the final ring diameter after turning. But if we were to cut the original ring to that diameter, obviously it would be less than 8 inches after turning around. So we need to add that fudge factor or padding to make sure that we have the 8-inch diameter left after turning. Well, that fudge factor or padding is built into this diagram in the clear white areas to the outside of each of these rings. So that's already taken into account in each of these. Actually, you'll find that the padding that I added here is a little bit wider than we might traditionally use. I thought we would add a little bit more padding than usual just to make sure you had some extra room to play with your first ring. Normally I would use about 3/8 inch padding total on both sides. This is about 3/4 of an inch total on both sides for each of the rings, but at least it gives you a little bit of extra room in working with your first segmented bowl. The diagram, as I said, shows the ring diameter for each ring, top ring being 9 inches, then 8.5, 8, 7.5, and 6.5. The base is a solid wood walnut base. We'll talk a little bit more about bases later in the video. In this particular instance, because it's a small bowl, we're using a solid wood base on top of each of the rings that will ultimately stack up. But this is the diagram that we came up with that illustrates again the effect of curvature on the strip width that we use. So now let's take a quick look at what the other steps are going to be now that we have the final design that we want to use for our project. Let's take a look at the various steps that we will follow after coming up with our design to show you the basic rough stages that we'll go through to end up with the solid wood bowl that we hope to end up with at the end. All right, now that we have our design finalized, this has given us the complete cut list that we need to produce the wood strips of the right length and the right width to be able to produce the segmented rings that will ultimately go into the construction of our project bowl. Now let's take a look at the various stages that we're going to go through during the balance of this presentation. Now that we have our design in mind and the materials list that we need that gives us the strip lengths and strip widths that we need, the next phase is going to be to cut those strips. We have the appropriate strips here already cut to the correct widths and approximately the correct length. These may be a touch longer because those are the length of boards that I had, but they're roughly the length called for in our materials list. These are the wood strips that we're ultimately going to go to the table saw and cut into the appropriate segment lengths. We'll focus a little bit more this time than we did last time on how to sneak up on the correct segment length using the table saw in this instance. The concepts are going to be exactly the same for sneaking up on that correct segment length, whether you're at the miter saw, the bandsaw, or the table saw. So we'll focus a little bit more on that. Also, I want to talk just for a minute about the type of base that we are using here. Again, it's a solid base. As we talked about last time, the preference on a small bowl this size is to use kiln-dried, quarter-sawn hardwood, if at all possible. and that's what we have here as a walnut disc. There are other kinds of bases that we talk about in the PowerPoint presentation, a little bit more advanced types of bases that we don't want to focus on here, only because we're assuming this is your first segmented bowl, but there are tapered plug bases, there are fully segmented bases, there are floating disc bases. The general consensus seems to be for bowls of this small size, where we're only using, this is a 4-inch disc and ultimately will be a little bit narrower than that. Using a solid wood base is fine. You're not going to have enough wood movement to cause any problems using a solid wood base. So that's what we're going to use in this instance. What we'll do again, now that we have the strips all cut to the right widths and lengths, we're then going to go to the table saw, cut the appropriate segments, again focusing a little bit on how to sneak up on that segment length, and we'll ultimately produce these 5 rings in addition to the solid base. These 5 rings, again, we're not going to show you how to glue and clamp them. We did that the last time. We're going to assume you can watch that video and see how to glue and clamp them again. We're going to review again quickly how to sand one side of each of those, since we're assuming, as we did in the last video, that you don't have a drum sander available to be able to sand both sides. So we're going to show you once again quickly how to sand one side of each using a disc sander on the lathe to get them ready for what's going to be the next stage, which is to assemble them one at a time onto a glue block. And we'll talk a little bit at that point about why using a glue block as opposed to any other mounting system on the lathe. We'll show you how to go about marking them so that you will achieve the one objective you really truly want to achieve, which is ultimately when you get to the stage of having all the rings finally glued in place, you want to make sure that all of the joints on the successive rings align correctly. As you'll see on the sample bowl of our project, all of these joints, these 3 joints in ring 1, ring 3, and ring 5, all line up exactly correctly. That doesn't happen by accident. Some people try to do it by eye. It can be successful, but more often than not, it isn't. So we're going to show you a technique to use to ensure that those rings are all marked appropriately, so that as you glue them together, those joints will, after turning, line up very, very nicely. And then we'll show you how to assemble them one ring at a time onto the glue block that you're using to ultimately mount on the lathe, so that you'll end up with a turning blank that looks like this. This is a blank that you can, given its relatively shallow depth here, this isn't terribly deep. This is one that you don't have to do in stages. If you're turning a particularly deep bowl, you may want to only do 2 or 3 rings at a time and then turn those before adding other rings. This one isn't so deep that that's really an issue. Still, given the type of glue block that I'm using, we're going to show you how to use a bowl steady once you get to doing the inside of this, because you will get a little bit of vibration that we want to avoid as we're turning the inside. So we'll turn the outside first, use a bowl steady on the outside when we're turning the inside. And then ultimately ending up with, as we said, the final project bowl. So let's get started over at the table saw and start cutting these strips into segments. First, let's make sure that we get the miter gauge set correctly over at the miter set for segments. Again, setting one pin on 0, the other pin on 12, and adjusting the miter gauge tightly against those pins. Now we're set at exactly 15 degrees. Right, and we have the miter gauge installed adjacent to the table saw blade with the throat plate removed. The reason the throat plate is removed is so that the blade can be fully raised in the table saw, and that exposes enough of the blade body so that the edge of the digital protractor will fully rest against the body of the blade without the teeth impeding a perfectly flat alignment of the digital protractor leg on that surface. We want to verify that the miter gauge is in fact set at 15 degrees. And also, this is the way you would set it if you didn't have a miter set or any other device to set it. Again, what we prefer to use in that circumstance is a digital protractor like this. These are considered highly accurate within a couple tenths of a degree. So what we're trying to do is make sure this gauge is set at 15 degrees. Again, remember where it would originally be at 90 degrees. We want to tilt this to 15 degrees, which would mean this angle, the corresponding angle, would be 90 minus the 15 or 75 degrees. So we want to make sure this protractor, when we set it against the miter gauge and against the body of the blade, is at 75 degrees, and you'll see this reads at exactly 75.0 degrees. So we know our miter gauge is set at exactly the degree setting that we need to cut our segments for a 12 segment ring. The next thing we need to do is to determine the appropriate setting for our fence so that we have the exactly correct segment length that we need for the first ring that we're going to cut. The way we do that is, of course, not to start cutting up our good wood that we ultimately want to use for our ring, but rather to use whatever scrap wood that we have. The width doesn't matter for this purpose. You can use, I typically use just some scrap 1.5 inch wide material. That seems to work just fine for this purpose. Use whatever scrap you have to sneak up on the correct segment length before you start cutting on the good wood strips that we're going to ultimately use for the final finished rings. We want to make sure, and this sometimes can take several cuts to get correct, we want to make sure we don't use up any of our good wood prior to doing the final cut. So the next thing we're going to do is get a rough setting with our table saw fence with whatever stop block we have installed. Again, remembering this stop block that I have here, as I mentioned during the first video, is a 3-inch stop block. All right, now looking at our diagram, we're going to begin by cutting the appropriate segment lengths for ring 1, and the segment length is supposed to be 1.7 inches. So we would take the 3 inches for the width of our stop block and add 1.7 to it. So I would set the fence at a little bit less than 4 3/4 inches, and we'll make a test cut, measure that segment length with a digital caliper, and then see how much more we need to adjust the fence to get as close to the 1.7 as we possibly can. And we'll measure this segment length with the digital caliper, and we'll see it is 1.75 inches. So we need to make the segment length just a little bit, about 5/100ths shorter, to get close to the 1.7 inch segment length that we need. Adjust it a little bit, take one more test cut. All right, in our second effort at getting the correct segment length, we're now at 1.697 inches. So that's quite close to 1.7. That's more than close enough for our purposes. So this is now finally set at the correct segment length for ring number 1. All right, now we're ready to begin our finish cuts on the ring number 1 strip. Remember, as we mentioned in part 1 of the presentation, squiggly line on one of the faces and a straight line on one of the edges, so that will assist us in our ring assembly to zero out any blade verticality issues. First thing we need to do is make the appropriate cut on the first end of this to get to the correct 15-degree angle, and then we'll start cutting the segments. right, now we have all 12 segments cut for ring number 1. The next step for that ring is to take them to the workbench, sand the fuzzies off, test fit them, and then glue and clamp them, let it dry so that it's ready for assembly. All right, now that we completed cutting ring 1 into the necessary 12 segments, we're going to do ring 2, but we're going to change this up a little bit. Instead of using the traditional standard miter gauge that came with the table saw, we're just going to show you what cutting segments is like using a wedgie sled and the assorted equipment that goes with a wedgie sled. All right, what we have on the table saw now is a wedgie sled built to the specifications from Jerry Bennett's Segeasy.com website, and we have set it using one of Segeasy's wedgies. This is the 12 segment wedgie. It'll be 15 degrees, just like the miter gauge, and the ultimate cuts 30 degrees included angle, but 15 degrees for each of the cuts. This is now set tightly all the way along the length on each side, so we know this is set correctly. And to use the wedgie sled, we use the strip in this fashion, and then without flipping it over as we do with the miter gauge, we simply move it up to the other arm, and we move it back and forth, and that automatically changes the angle at which we're cutting the strip. So we move it back and forth. We have instead of boring you with showing you how we set this, once again sneaking up on the correct segment length, we already preset this to the correct segment length, so we're good to go. We've taken out the standard throat plate and replaced it with an off-ramp kind of throat plate that results in each of the segments falling away from the table saw blade. So that makes it a little bit easier to retrieve the segments rather than having to stop the saw after every few segments. So at this point, let's cut this particular strip into the appropriate 12 segments using the wedgie sled so that you can see how that works. For ring 3, we're going to continue to use the wedgie sled and the standard stop block for the wedgie sled, but this time I've taken off the typical off-ramp throat plate and installed instead what's called a flipper system throat plate that will move each of the segments away from the blade as you cut it. And what will happen will be this pin will engage this arm here and flip the piece away once you bring the sled back, and it flips it away from the blade. This has a pin in it that stops the arm from swinging back into the blade, so it's nice and safe and secure. This way, again, you don't have to ever stop the saw to move pieces away as you do with either the standard miter gauge or occasionally with the off-ramp type of throat plate. So let's give this one a try. As you'll see, I cut a few extra just to make sure, in case it turns out there's any knot or other imperfection in any of them. If I have the space, I'll cut a few extra just in case, but hopefully it'll end up working just fine with 12. Now that we have all of our strips cut into the correct segment lengths, the next step is for us to use the test fitting and gluing and clamping techniques that we showed you during the first part of this video. For each of these rings then, we will test fit them to make sure, using a zip tie to ensure that they fit correctly before we glue them. Once we're sure they fit correctly, then we go about using the blue tape method to glue and clamp them and let them dry. And once they are all dried, we'll end up with a nice stack of completed rings ready for the next phase, which is going to be sanding one side of each of the rings on the disc sander on the lathe, assuming again that most of you do not have a drum sander available in the shop. So we'll make available a sanding disc, make use of a sanding disc on the lathe to accomplish that same task. All right, now that the gluing process is over with and the rings have appropriately dried, the next phase is going to be, as I indicated, for us to go to the sanding disc on the lathe to sand one side of each of these because again, we're assuming no drum sander. You have to sand one side on the disc sander, and then we will mount each one to the glue block to ultimately come up with this blank. But again, as I mentioned at the outset of the presentation, we need to, after the sanding is completed, we need to mark each of the rings to ensure that they are appropriately centered so that the joints align correctly. And we'll do that after we get done with the sanding phase. All right, this next stage is going to be sanding one side of each of the completed rings. As you'll see, I have used, as we showed in the last video, 4 pieces of double-sided tape on the back side of this and simply glued it. This is ring number 1, and have adhered it with 4 pieces of tape to just a scrap disc that we'll use to hold it against the sanding disc. Witness marks are already here from the original markings on this particular ring. We're going to do the same thing for the first 4 of the rings. The 5th ring, just for interest purposes, we're going to show you how easy it is to sand both sides really quickly on a drum sander. So let's get started with the first of the 4 rings we're going to do on the sanding disc on the lathe. The next step is going to be for us to pry this off of the plate and do the next ring. Again, slowing down the sanding disc a little bit at a time because otherwise it might spin off the spindle, which we don't want. All right, now we have rings 1 through 4 all fully sanded on one side, and they're ready to go to the next phase of assembly of the turning blank. First, we want to go over to the drum sander to show you how easy it is to use the drum sander to get both sides of ring 5 sanded. All right, let's talk a little bit about why we only sanded one side of rings 1 through 4 over at the sanding disc on the lathe, and that's because we can't do both over on the sanding disc and ensure at the same time that each sanded surface is parallel to the other side. We can do one side and then adhere that to the glue block and then turn this face smooth, sand it while it's on the lathe, make sure it's dead flat before we then take the previously sanded one side of the next ring and put that onto the glued assembly as well. So that's why without a drum sander, we can only do one side at a time on the disc sander, and then we have to install the rings one at a time on the glue block to ensure that each surface is appropriately sanded and we have a nice joint between the rings each time. All right, the next step we're going to show you is one that really isn't absolutely required before moving on to trying to mark these for joint alignment purposes. But since we're going to be ultimately stacking these rings for marking purposes, it is useful to try to eliminate any high spots that may exist on the unsanded sides of each of these rings. Again, as I said, it's not essential to do, but it makes the stacking process and marking process a little bit easier if you don't have any high spots on the unsanded sides of these rings. So what we suggest you do is to take the unsanded side of each ring and simply run it quickly across a sanding board, which is nothing other than this is a piece of MDF to which I've adhered some strips of 180 grit sandpaper, and just run it across here a few times to take off any high spots. Again, we're not worried at this point whether that's completely parallel to the other side. We'll straighten that out once we get it glued onto the glue block over at the lathe. But at least for stacking and marking purposes, we want to try to take off any high spots real quickly. So, and we've got some of the high spots removed, same on the next one. Rotate it. Again, just takes off any high spots so that we get a better, more even stack. All right, the next phase is for us to mark each of the rings in such a way to ensure that while we're gluing these rings one at a time onto the waste block, that we're able to align them with the appropriate joints on the rings that are going to be above each one, so that ultimately after turning, all of the lines line up as we showed earlier on the finished piece. The first step is to take ring 1 and to mark on the surface that is going to be facing up from the glue block. The surface will be facing up. We're going to put a little pencil tick mark right in the middle of two opposing segments. And we do that most easily. I mean, you can do it with any ruler. Most easily it's done with a center finding ruler, where you simply hold the ruler centered between the two joints on either side of this segment, and you simply mark where the 0 is on the center finding ruler, or simply use a traditional ruler and find where the midway point is for whatever that measurement is. But we simply put a pencil line again right in the center of each of the two opposing segments. Make sure it's on the same side, and you would do the same thing on this opposing segment on this ring, and then this is the joint that will the next ring will go on top of, and we'll flip them over to show you the next phase, which is to ensure, and we'll do this a little bit differently in just a second, to ensure that those tick marks line up exactly with the joints in the middle of the next ring. And what I'll do to highlight that joint, and we're doing it only for purposes of the video, you don't really need to do it in person, but so that you can see it, I'll put a pencil line over the joint so that you can see a little bit better on video how these need to line up. And what we'll do is, again, take the tick mark that is in the middle of that one, line it up with the pencil line highlighted joint on both sides. And then the next step to ensure that we're roughly centered is to take a traditional ruler and measure the distance from the flat surface of this segment out to the point of the next ring, and ensure that you have them both exactly centered on both sides here. That means you're going to be fine since you've already got the tick mark lined up on this joint. As long as you're okay in this direction, you're fine all the way around. So once you're at that point, simply put a mark here, so that will guide you in placing this ring. When you go to glue the next one on, simply put those two lines there. I extend them out all the way to the side because that line, since it's adjacent to a segment that is getting glued on, that line may get obscured by squeeze out. So I extend both of those lines, and it makes it much easier when you're going through the gluing process. Whoops. Makes it much easier to align the ring correctly. So it goes right up against that line on both sides. Goes right up against the line on both sides. And that way you have it perfectly aligned, so that if you follow that same process on each of these successive rings, marking the centers of opposing segments and centering it on the next ring up with those marks, then as you glue the assembly together following those lines, ultimately the joints will all align perfectly, as in the finished bowl that we showed earlier, where each of those joints lines up very nicely, and that's the objective we want to achieve through this process. So the next step is to continue to make those same marks on each of the successive rings. All right, next we want to talk about how to mount our base and segmented rings onto the lathe. There's any number of techniques available to turners, not within the scope of this presentation to go through all of those, but we're going to use what is the, I think, most traditional way to mount a bowl of this nature onto the lathe, which is using a glue block, a waste block. In this case mounted to a faceplate. You can use a direct thread version. This is created using the Beal thread tap. Certainly you can use something like that, or something that's faceplate mounted like this. This is the one that we're going to use. Then we're going to show you how to go about mounting to the waste block the base and the ring number 1, and we can do both of those here at the lathe prior to taking it over to the workbench to apply the ring number 2, to glue ring number 2 onto this assembly. Right, now we're going to show you how to mount the base to the waste block. For this purpose, demonstration purpose only, we're just going to use double-faced tape because we already have the fully glued assembly ready to turn. But here we're going to show you how you would do it, assuming that you would apply glue to both the waste block side and the base side. I'm simply using the center hole that I made when I used a compass to draw the circle that I cut out on the bandsaw to use for the rough base blank, and we simply use that center point to apply pressure to adhere this to the waste block. Again, let me emphasize, you need to make sure that face block face was properly turned smooth, checking it with a ruler first before you adhere your base to it. The same is true once you get the base applied. Check this to make sure it is dead flat. If not, turn it, sand it, make sure that it is completely flat. Use your ruler to verify that. Hold the light if you need to up underneath it. If you can see light at any point, it's not completely flat. You want to make sure it's absolutely as flat as possible before you adhere ring number 1 to it. But assuming this is nice and flat and you're ready to go, we would then apply ring number 1 to the base. And again, we're going to, for demonstration purposes only, use double-faced tape to apply ring number 1. And because this has a reasonably round center to it, we're going to apply it adhere it to the base using pressure from a cone center mounted in the tailstock, so that we'll make sure that it's reasonably well centered on the base when we adhere it. We want to make sure that the cone center that we're using does not protrude all the way through. We don't want that to inhibit it being pressed fully against the base. So we get this centered and then simply apply tailstock pressure, gluing both surfaces. Again, we're just using double-faced tape for demonstration purposes. You would apply glue to both surfaces, apply pressure from the tailstock, and let that sit for a few hours before you would take it over to the workbench. First thing you would do before gluing it onto the to ring number 2 is to make sure this surface is properly faced. Remember, we had previously sanded the side that goes against the glue block. That's done. This side was not, so we would make sure this was fully turned smooth and straight, and again using a ruler to ensure that it's dead flat. Once that's done, then we would take this assembly over to the workbench, and that's where we'll show you the technique that we use to make sure that the joints are properly aligned using the tick marks that we've already made on the opposing segments on ring 1. We'll align those with the appropriate joints on ring 2 and begin the process of gluing that ring on at the workbench before we bring it back over to the lathe to turn the outside surface of ring 2 nice and flat before we go through the exact same process to apply ring number 3 and consequently rings 4 and 5 as well. All right, now we've removed from the lathe the glue block assembly with the base and ring number 1 glued onto it. The next step is for us to use the alignment marks that we made earlier to begin gluing each of the rings individually to this assembly. And the first thing we're going to do, of course, is to begin with gluing this assembly to ring 2 using these alignment marks that we made. Again, reminding you that we highlighted the joints here with pencil. You wouldn't normally see these here, but we highlighted them with pencil just so that you can see them a little better. Normally what we would do is apply glue, of course, to both surfaces, to ring number 1 and to the inside of ring number 2, and then we would align the tick marks with the joint lines that we previously highlighted, making sure that they are aligned as accurately as we can get them, and then we simply allow the glue to tack for a few minutes, 3, 4, 5 minutes at the most, so that we avoid having happen what frequently happens if we would try to apply pressure here to freshly applied glue. These rings move quite a bit on each other, and therefore they would move out of alignment. We don't want that to happen. So the best way to prevent that from happening is to simply let the glue begin to tack for a few minutes, and then we would apply weight. In this instance, we're going to use a couple of hand weights that ought to be sufficient for this purpose. Other segmenters use different techniques to try to prevent the movement as you're trying to align the rings together like this so that the joints line up correctly. They may apply salt to the glue joint to stop it from moving. Others might apply with hot glue some temporary blocks to stop it from moving around. You can do those things, but frankly, it's just as easy, even easier from my perspective, to use the technique where you simply let the glue tack for a few minutes and then apply weight to it. At that point, I think you'll see the rings will not slide against each other at all. So you would simply apply whatever weight you have in the shop. This is, I think these are 5 pounds each, so there's 10 pounds of weight on it. That's certainly sufficient for this purpose to adhere these rings to each other. Let that glue set for a couple of hours would be best before you then take this back to the lathe and surface the outside of ring 2. You would turn that with your bowl gouge very lightly, then sand it until you check it with a ruler and get that nice tight joint. And once you get that nice tight joint, then you bring it back over to the workbench, take out ring 3, and use the same exact process to align the tick marks on ring 2 with the highlighted joint lines and side-to-side lines that we installed on ring 3. Same process for the remaining 2 rings for rings 4 and ring 5. Same process. All right, now we have our previously assembled bowl blank mounted on the lathe. Again, it's mounted on a glue block. We have tailstock support using a traditional live center on which is reverse mounted a part of a cone center. This one's from Steve Sinner's Advanced Lathe Tools. Makes a very handy tailstock support for a bowl of this type, so reduces vibration and whatnot. It is all set to go, and now we'll begin turning the outside of the bowl. All right, we just showed you the rough turning of our blank, a previously glued blank on the lathe. We wanted to make sure you had an idea of how one would go about turning off what are clearly very rough edges from segmented rings, a little bit different than most of the stuff that some turners do. So we wanted to show you how those rough edges get turned off, both inside and outside. The rest of the bowl is finished very much the same way as any traditional bowl would be finished. Everybody here is likely a bowl turner of one sort or another, so nothing unique about turning the rest of the bowl. We would use whatever profile you want on the foot. I happen to use this profile that you see here. Nothing magic to it. It's whatever profile you want, either on the foot or even on the rim of the bowl. Use whatever profile you happen to like. Again, turn to whatever thickness you want. These walls are between 1/4 of an inch and 5/16 of an inch thick, reasonably thin for a segmented bowl. This is a very lightweight bowl, finished in this fashion, or turned in this fashion. Once we finish turning it on the lathe and sanding it, I usually sand down through 400 grit. After that, I take it off the lathe and apply finish to it. I am a big spray lacquer user, so this has a number of coats of Whattam matte lacquer on all sides. Seems to be a nice durable finish for most of what we would use it for. So use whatever finish you want of your choice. On wood of this type, which is just walnut and maple, you can use pretty much any finish that you find acceptable for your bowls. And with that, hopefully you'll end up with a nice first segmented bowl turning project. We suggest that you give it a try, see how it turns out for you, and we wish you all the best in your segmenting journey.